Hi, my name is Deshir Hill, and I will be presenting Piezo 1 as my protein. I will be bringing out this model in a few. The mutation of Piezo 1 is Arginine 2456, which is replaced by Histidine 2456, Histidine R2456H. The normal function of Piezo 1 is that it transduces mechanical forces and it regulates nitric oxide formation. It aids in skeletal growth, vascular structure in the development and adult physiology, and it aids in the perception of touch. It is categorized as a receptor protein. This is because it converts physical/mechanical stimuli into electrical/biological signals. This protein is normally found in intracellular plasma cell membrane, and the types of cells that contain this protein generally are red blood cells, embryonic endothelial cells, and it can be found in lung and bladder cells as well. The types of organisms that generally contain this protein are eukaryotic cells, animal cells and plant cells, and protozoa, but not yeast and bacteria. The protein becomes more active in my interpretation of the data because the mutation allows excess calcium to enter the red blood cell. The mutation causes the ion channels to close slower and can lead to cell dehydration. It's activated by stress, and is required for elevated blood pressure and physical activity, but not inactivity. The main functional groups presented in the original amino acid side chain is a carboxyl group and an amine group. It is also a hydrophilic group as the amino side chain. It is positively charged because of the hydrogen bonds, and I could characterize the size as large. There's approximately 2,500 amino acids long. As for the types of interactions in the original amino acid, it can participate in, due to polarity, arginine can form hydrogen bonds with polar groups to contribute to the 3D folding of the protein. Now, we're going to move on to the mutation. In the mutation, there is also a carboxyl group and an amine group. And the properties of the new mutated amino acid side chain is hydrophilic because of the hydrogen bonding, although it has a hydrophobic gate in the inner pore helix of the piezo channels. It is known to be neutral, and it can be either positive or negatively charged depending on the pH balance. This also is characterized as large, so there is no change in the size after the mutation. Differences in the interaction can form hydrogen and ionic bonds between the original and the mutated amino acid side chain. This is because histidine can be positively charged or negatively due to the pH balance, but it is generally neutral. For my assigned mutation, which is Arginine 2456 replaced by histidine, the protein is triggered by tension, and it closes the ion channel slower, which allows excess calcium to enter the red blood cells. This can lead to cell dehydration. It can lead to a rare autosomal dominant genetic disorder characterized by dehydration, stomatocytosis. Symptoms can be fatigue due to disproportionate degree of anemia and more. So I'm going to move on to the build of my protein. And this is the overall shape. I'm going to show from different angles. The piezo One has 3 blades here, and then it also has 3 beams, and then it has an ion channel, which I focused on making as best as I could in the middle. So I used fuzzy wires as my material for my model to mimic the shape. It is a propeller-shaped trimetric complex. It's composed of 3 identical subunits that come together to form the center membrane spanning ion channel, which is here, and 3 beam-like structures, which is the pink, fuzzy wire pieces, and 3 curving blades that extend away from the channel. I created the model in a spacious manner to the best of my ability to be able to also show the subunits. I built one model to show where the mutation occurs, which is in the ion channel. I also built calcium ions to be able to use to show. It's important to know that the pore of the Piezo 1 protein is not pressure sensitive, but the ion channel is mechanically sensitive. And just to show an example, generally, it would be when I say that the excess calcium is being, when the ion channel is being closed slower, this would be the ion channel, and this would be, it would be shown that once the calcium is put through, it's closing at a slower manner and allowing more calcium to go through than it generally would if it was not mutated. I would also say, as previously answered, the assigned mutation affects the protein's function in the manner of, it affects the channels, which is here in the middle. It affects the movement of the channel and because they close slower. And arginine is a complex side chain and that is amphipathic, which means it has both hydrophilic and hydrophobic parts. It contains a positively charged guanidinium group, and it is highly polar at the end of a hydrophobic allopathic hydrocarbon chain. Histidine is an amino acid, a carboxyl acid group, and it has an organic R group connected to a central carbon atom. It's polar covalent and positively charged and hydrophilic. It depends on the pH of the environment where it is generally neutral, as it was previously stated. So to identify where the mutated amino acid is located within a protein, I wanted to make sure to properly represent my model by showing the cap, which is the extracellular cap, which would be, if my hands were the membrane, this would be where the proteins, where the calcium cations are falling through here, with the cap that goes through the ion channel. It has a C-terminal extracellular domain, and it has the blades and the beams. The outside membrane, so a limitation of my model specifically would be that I don't have an outside membrane to show. I have just the model of the protein, but my hands could act as a cell membrane in a way. And I also don't have a way for the cytoplasm to be shown. And the replacement of the arginine to the histidine cannot be shown as well. Another limitation would be this model doesn't show the fatty acids of Piezo 1. Thank you.